Hello everyone. Exam 2 will be held in about a week from now. If you cannot at all attend the exam during the provided 24-hour window period, please make sure to fill out the exam 2 conflict form at least by this week Friday, which is October 30th. The link to the exam 2 conflict form can be found on the course website surveys page. Before we get started with today's lecture topic, I want to go through a mini quiz. This time I'm going to use Jupyter Notebook to go through the questions. There is a template notebook file for you to download from today's lecture code link in order to follow along. You can ignore the code within the first cell. That just enables us to increase the width of the Jupyter Notebook cell. Let's go through question 1. Is mystery a recursive function example or a function object reference example? The definition for the mystery function is provided below that question. Go ahead and pause the lecture video here and provide the answer to this question as a comment in the comment section. Let's first discuss how to identify recursive functions in general. Whenever you have a function which calls itself, that particular function is going to be a recursive function. Let's go through the definition of the mystery function. The mystery function is calling itself, so clearly mystery is an example of a recursive function. The only reason as to why I named this function mystery is because I wanted to quiz you on what exactly this function is doing. Please don't name any of your functions or variables mystery. That doesn't make any sense. I'm still seeing a lot of students who are using random names for variables and function names. Please make sure to fix that as soon as possible. Only if you use meaningful variable names and function names, somebody else who is going through your program can understand what exactly your code is doing. It's one of the most fundamental things that you should learn as a programmer. Let's go through few invocations of the mystery function and let's see if we are able to think about what exactly mystery function here is doing. The first invocation is for mystery of 2, 1. The arguments 2 and 1 go into the parameters x and y. So x is going to be 2, y is going to be 1. I just have positional arguments here. What are we doing inside the function? If y is 1, we are returning x. So mystery of 2, 1 is simply going to return 2. Mystery of 2, 2, x is 2, y is 2. What are we doing if y is not 1? We are recursively calling the function. We are saying x into mystery of something, x is 2. Mystery function recursive call is made with the arguments x and y minus 1. X is 2, y is 2, so y minus 1 is 1. I already know mystery of 2, 1 is going to return 2. How do I know that? We just executed that particular invocation. So this computation is going to return 4. Mystery of 2, 2 returns 4. Mystery of 2, 3. Since y is not 1, we are going to make the recursive call again. So we are going to say 2 into mystery of 2, y minus 1 is 3 minus 1, 2. Mystery of 2, 2 is 4. So mystery of 2, 3 is simply going to return 8. Are you able to predict what mystery of 2, 4 here will return? If you were thinking 16, then you have the correct answer. The mystery function is no longer a mystery. It enables us to compute x to the power y over here. The power computation is naturally recursive. That's because you can rewrite x to the power y as x into x to the power y minus 1, correct? Whenever you have such a structure, it makes total sense for you to write a recursive solution because you are able to define the problem in terms of a smaller version of the same problem. Let's go through question number 2 here. It's asking if raise 10 is a recursive function example or a function object reference example. What is the definition of raise 10 function? It's taking one argument which is defined as the parameter exp, and it's just simply calling mystery function by passing the arguments 10 and exp to it. We are directly returning whatever mystery is returning. So clearly raise 10 function performs 10 to the power exponent over here. How are we using this function? We are not calling it directly. Rather, we are passing a reference to the function object for raise 10 as an argument to the map function call. Recall that map enables us to apply whatever function reference we pass as the first argument to each item of the list which we pass as the second argument. Now if I execute this particular cell, we are going to get 10 to the power 1, 10 to the power 3, 10 to the power 2, and 10 to the power 4. Why is this code snippet providing a list as output? That's because we are typecasting the return value from the map function to a list. Recall that map function returns a generator object. In today's lecture, we are going to learn all about generator objects. Let me switch back to the slide deck over here. Generators are special kind of functions which enable you to keep running while also giving back some result to the place where you're calling that function. That's unusual, correct? So far, we have only dealt with functions which executes every line of code and returns the final computation back to the place where you're calling the function. Generators are going to be exceptions for that. Let's first go through function examples, which are regular functions, before we talk about generators. This is going to be good practice for you in terms of exam 2 review. So please make sure to pause the video here and go through this snippet of code on your own if you want to get some experience going through and reading code over here. So I have a function definition on the top here, which is for the function get underscore one underscore digit underscore nums. Where am I calling that function? I'm calling that function as part of this for loop statement. Let me ask a question first before we go through the code snippet. How many times do you think the word start will get printed when we call this particular function over here? Go ahead and pause the video and write your answer as a comment. If you were thinking that start gets printed just only once, then you had the correct answer to my question. Why is that the case? Recall that whenever you have a function call, the entire function call completes and whatever is being returned by that particular function will get replaced in the place of the function call. So let's go through the function to understand what will be the return value out of it. So we are making the function call one time and the first line will display start. Then we are initializing an empty list. After that, I have a while loop. The counter for while loop is I. So the increment is going to be 1 here. So I'm going to run this while loop from 0 through 9, correct? What am I doing inside the while loop? I'm just appending the value of I into the list nums over here. Then I'll be printing end and I'll be returning nums, which is going to be a list which contains the items 0 through 9. So you can imagine that in place of this function call, you have that list which you're going to iterate over in your for loop. What are you doing in the for loop? You're taking out each item in your list, putting it into a variable called x, and you're just printing x. We are not using the range function for this for loop, so we are iterating over values and not indices. Please make sure to understand the difference between the two. If you think about a timeline diagram for this particular example, where you have time as your x-axis and different blocks to denote various snippets of code here, your timeline will kind of look like this, correct? You will have first the execution associated with the get underscore one underscore digit underscore nums function, which I'm using the black block of code to denote. So you're going to display start first, and you're going to populate the nums list, and then you're going to display end. Only after this function is done executing, this particular gray block of code is going to execute, which is the body of your for loop over here. And you'll be looping over every item that you generated as part of the nums list which got returned. Let's go through one more example here. Go ahead and pause the lecture video here, go through this example, and see if you're able to identify what exactly this code will do. Assume that there is a definition provided for the s underscore prime function, and as per the name, the s underscore prime function is going to return true or false depending on whether the passed argument is a prime number or not. If your answer to this question is that this particular snippet of code will run into infinite loop, then you had the correct answer. We have a similar structure as in the last example. We are calling the function as part of the for loop statement. What are we doing inside the function? We are printing start, and then we are initializing an empty list called nums. But our while loop here is an infinite while loop because we are saying while of true. What are we doing for every instance of the while loop? We are checking iteration of the while loop, excuse me. For every iteration of the while loop, we are checking whether that particular number is prime or not. And if it is prime, we are going to append that to the nums list. So the main problem with this particular snippet of code is that the getPrimes function call will never get over. You can imagine that if you're asked to find all the prime numbers, it will take forever for you to do that, correct? Because you have infinite number of prime numbers. What we really want in this case is a generator in order to make the get underscore primes function work. So let me first give you an overview of timeline which you can come up with for a generator. So let's assume that get underscore primes function is a generator here. What exactly a generator will do is it will compute one value and it will go ahead and give you the value to the place where you're calling that particular function. So step one is going to be get primes will just run long enough to determine the first prime value, and then you're going to get the prime value back into the variable x, which is your for loop variable here. So we are going to print that number which get underscore primes computed, and then we are going to go back and resume get underscore primes in order to get the next prime number. So you can imagine repeating this forever for this particular example. This kind of a stop and resume behavior is what defines a generator. Whichever functions which perform the stop and resume behavior are called as generators. Let's talk about what enables us to identify a function as a generator. Look into the definition for the particular function. If you're able to find a yield statement, then that particular function is going to be called as generator. One thing that might bother you is that generators are totally different when compared to the other function examples that we have covered so far, correct? Why is that the case? All other regular functions execute all lines of code within the function and just return the final computation as the value. Whereas generators just have this stop and resume behavior where you keep getting values out of the function before even it completes its entire execution. So the creators of Python were debating whether they wanted to use a different keyword in order to denote the definition for a generator as opposed to the definition for a function. They debated whether to use the gen keyword instead of the def keyword. Who exactly makes decision about these things? It used to be a person called as Guido van Rossum. He used to be Python's benevolent dictator. So he used to collect all the pros and cons associated with any specific question that he wants to take a decision on. And then he'll make a final pronouncement as to what the final behavior is going to be in Python. So he went through a lot of arguments for pros and cons, and he decided that just having a yield statement within a function does not make it too different from a regular function. So he decided that we are not going to use the gen keyword and we'll be using the def keyword itself for a generator. Let me show you what this link talks about. So I already have that link open over here. If you go through that particular link, you can go through all the pros and cons and the discussion related to this particular question. All of this is well documented in Python. That would be really interesting for you to read in order to understand the history of Python in terms of decision making about any conflicts. I just want to take this opportunity to show you one more thing. You can find the documentation for any built-in function in Python by just searching for the function name. For instance, I can say sorted documentation Python built-in, and that's just going to get me the documentation associated with that function. This version is a detailed version where you have example function calls for sorted. If you click on the actual function definition, you should be able to see the description for each of the parameters associated with the built-in function. You can always go through the Python documentation in order to understand various parameter options for all of the built-in functions. I'll wrap up this video here. In the next video, we'll go through detailed examples of generator functions in order to understand the yield statement.